Good afternoon. Let's get started. We had a good lunch, so I'll try to be a non-Finn, even though I'm a Finn. So we are considered to be very shy and modest. Hence, I'll start off with a short thing about Wärtsilä. Yes, decarbonisation, I think that's all. For us, it's marine and energy. We actually celebrate 190 years this year, even though, of course, that's a bit of a stretch. The marine story started in the 50s when we delivered our first four-stroke engine, own design. And hence, it's been after that upwards. So this is what we want to do, which, of course, fits the theme of the day, and is one of the reasons why we are in this CHEK project. So it is all we've done here is on our strategic roadmap to enable sustainable societies, and that's fundamentally it. You might or you might not know, but as we are not in the consumer segment, business to business, so we service or maintain one way or the other, you could say, over half of the world's fleet. So we have, I'm not saying we have our engines on all vessels, of course, in these, but there are other appliances that we have. We are present in 180 countries, and 50% of our sales come from services. So maintenance and these days maintenance agreements, and how we together with our customers can take this forward. Numbers, 80 countries-ish, 130 nationalities, and I think this is our strength, that we have local people on the ground, so to speak, or in the harbors. In this very small city of Vaasa, where we are located, which is it now 70,000 people thereabouts. In Wärtsilä, we have 50 nationalities working in Vaasa, so I think this shows our strength. And yes, there's a lot of talk. There's a lot of visions about the decarbonisation of the future, both energy and marine. But we all know, of course, that in the marine segment, less than 1% of the fuel used is non-fossil. So we still have a stretch to go compared to, for example, power generation, windmills, etc. I think the world is over 30% now. So that's one thing. Technology development clearly on our sort of agenda, and then connectivity, data, and how we can predict the maintenance need and service needs of our vessels. And this is fundamentally the steps we are taking. And at the very high end, that we go into a sort of symbiosis with our customers, meaning that if we together with our customers succeed, then we also get something. If we do not, then we also get a slap on the fingers. So we need to succeed together with our customers. About the fuels, yes, we've done a lot. We are still doing, and will continue. The list of today, I think, there might be ethane missing, for example. But if I'm being sort of a modest Finn and not bragging too much, everything that burns and burns well, we could do. The question is, of course, then what are the consequences on the infrastructure, etc. And I think this is very topical as well, and hopefully tomorrow get some insights into the port's view on that regarding ammonia or for example, hydrogen infrastructure and the readiness of that. Right. Then we jump to the CHEK technologies. This is a summary of the technologies that we developed in CHEK together with our partners here. So I'll end with the hydrogen engine concept. We have the automated route planning tool, which was mentioned already. Then we actually did over the air software update. So this we did a real test. We connected, okay, not to a vessel, but we connected over the air to our engine laboratory in Spain, Bermeo, and did this test. So we proved it can be done. For cybersecurity reasons, we do not do this sort of with our customers. The customers in question need to physically open a link before we could do this. So we are, in that sense, cyber secure. As you might or might not know, or if you don't, you should know that the biggest cybersecurity threat is the human being. So how we act and how we follow the procedures. Hybrid and cold ironing, yes, done. And then the scalable power plants concept, which will come next. And also, of course, this then goes to the gate rudder. So Wärtsilä in this consortium had two legal entities, so Wärtsilä Finland and Wärtsilä Netherlands. And Wärtsilä Netherlands did the gate rudder. And of course, we had linked parties as well. So Wärtsilä Italy, Wärtsilä Norway. So we sort of have quite a broad participation here in this project. And also we did together with Lloyd Shield, as I remember, wasn't it? Yes, these experiences. So not only going into the technology, but also the human side and behavioral thing, that how can your behavior actually impact the greenhouse gas emissions? And I think that's very, very important as well. Right, so let's go to the maybe main beef here, the scalable propulsion powertrain. So this is what we did for the bulker in question. So replacing, in a sense, and then if you wonder why are we in this and why are we together with, for example, wing sales, shouldn't that be a contradiction that an engine manufacturer is actually together with the wing sales technology provider doing collaboration? Well, we don't do two-stroke engines, so we check out the two-stroke, put some wing sails on, and then we put in two four-strokes. So then we can enter segments which is not in our ball court, so to speak, today. So hence there, of course, always needs to be an interest of doing further business to join these kind of projects. But fundamentally, we have batteries, the cold ironing, and then, of course, also here the Climon's turbine to make electricity out of the waste heat recovery, two DF engines, auxiliary, and of course gearbox and PTO, PTI, and controllable pitch propeller. Now, this of course makes sense when we put wing sails on the vessel, because there is then a very variable need of engine propulsion power, and in order to be full flexible, we need to have all these ingredients to get the best energy efficiency out of the vessel in question. Right, so this is without taking into account wing sails. So this is just the powertrain compared to baseline, plotted against a speed against the baseline two-stroke engine with fixed pitch propeller. So clearly you can then see that the slower we go, and this is now without, as said, any wing sails, but the slower you go, the bigger is the benefit of having our solution. The reason being then that at some stage you can shut down the other engine, run the remaining engine on a higher load, higher efficiency than the two-stroke, and hence you will get the added value here. So when you combine this then with the fixed pitch and the wing sails, and you can then of course use much less power than actually needed. I think in one of the simulations that Delta Marine did with the given wind conditions, weather conditions, if this then has a nominal power, was it 6 or 8 megawatts? At some favorable winds, the power need was 1 megawatt. So I mean, it's not a lot. And then if you take in the possibility of even doing hybrid, if there are more sails or even more favorable winds, then this could really be something. Same curve then, of course, when we are in scantling draft. And clearly, of course, if we go to higher speeds, then of course the traditional one solution is better, of course, due to some of the losses that the gearbox, etc., makes. But the flexibility is showing here that the flexibility gives a better, wider operational profile. Then I wanted to lift a couple of other things that we did, so which will become of essence in the future. So fundamentally, as the fuel, in this case LNG or bio, and the methane number of the fuel, so the purity, if you may, changes depending on where you bunker, etc. And then you might need to to change the settings on the engine in order to optimize it for a lower methane number fuel. If you then run better fuel, you will not get the benefit. But we made here a actual change. When we started this project, the idea was to have a gas analyzer after the tank to then give indications to the engine, but we live and learn. Hence, we can, based on the combustion and the parameters we see in the combustion, deduct what level the fuel is and hence retune the engine and keep that sort of optimized all the time. Now, you might think that this is no biggie, but considering how much fuel the vessels use during a year, then if you can take down a few percentage, that's money in the bank. And then I wanted to lift one more thing. So this waste to power, even though it was a sort of a feasibility, and this might also be interesting to discuss tomorrow with the synergy and these ports, that if you could burn the waste, this is for the cruise ship, of course, as they accumulate a little bit more waste than the bulker. If you could burn that and make it into energy, you could say, was it up to 2.5%, which is not a small thing. And you would not have to pay the harbor operators for disposal of the waste. That's, of course, good business, and hence that might be in a bit of a contradiction with the harbor operators, and this is something to be lifted. And today is not allowed, so this is also to be presented and lifted up to the info paper we are writing, or BMW is writing to IMO. And then even though Mia already mentioned this, but I think this was a true collaboration in the sense that we opened up and we could do this kind of black box simulation, that we have our model and then run that through Delta Marine's model, or they give input and we take that in and then we give output to them. So without actually then going into each other's sort of secrets of what this is, but still we can exchange data. So I think this is extraordinary and should not be sort of forgotten, and I hope that we can do these kinds of activities with other players, and other players can do this with us as well in the future. Yes, and then before we jump into the hydrogen engine, interesting as such, was mentioned earlier that we did not consider, of course, at this stage, the tank capacity needed for hydrogen or for other fuels as matters. Yeah. So if this hydrogen would be compressed 350 bars, you need 20 times the size of the tank in order to get that. So that sort of gives the deep sea shipping a bit of a challenge. And even if you would liquefy it, you need almost more than 7 times the tank. So hence this could be for cruise, providing that the cruise liners or the harbors have infrastructure, and they usually only run a day or two, or if not that even, before they're in next harbor, except for the crossing, of course. So that's why, in theory, hydrogen could be an option for cruise vessels in the future, providing that there is infrastructure. Then deep sea, of course, is a bit of a challenge. And even though we would like to find a silver bullet here when it comes to future fuel, there is none yet, at least. And many of these fuels are not drop-in, so you can't mix per se unless you have a dual fuel engine. So you have 2 different fuels going into the combustion chamber. But it's not only the engine, it's also the infrastructure on board. So methanol you could put in steel tanks with some coating. Ammonia, no, you need stainless. So that's, of course, then also a bit of a biggie for retrofitting. Yep, and of course hydrogen has the nasty thing of escaping through impurities in the steel, but this we believe that will be, of course, fixed in the future. Then a little bit about the hydrogen engine testing that we did. So this was from day one. You could say CHEK, Wärtsilä, hydrogen engine was from day one a stepping stone, our first phase in this development, because we knew that you do not develop such an engine in 3 years. You get a good start, which we did, but the data we have gathered helped us then to simulate and give the numbers to Delta Marine for this future hydrogen engine simulation on the cruise ship. And as mentioned, there is very low when it comes to, if any, if you're really scrutinizing it, the only sort of bad things come out is due to the lubricants, and we believe that NOx, or we know that NOx we can take care of with SCR. So as such, that is not an issue. The tests were being made on a 31 single-cylinder, full-scale single-cylinder engine in Vaasa, and we will release a small info video of that testing, which was witnessed by MSC, Lloyd's Register, and University of Vaasa last summer. And this hydrogen engine journey of ours continues. So by end of next year, we will have launch our first concept, and we have promised to the Finnish government that in case a customer, and it's very close, a customer would buy, this is on our land-based power generation side though, but the engine as such is more or less the same then, would acquire 2 hydrogen engines to run a balancing power plant in Finland, then we would be ready to deliver that by end of 26, have that running. So this is how serious we are with hydrogen engines. And I think this summarized the feeling of the collaboration. Thank you to University of Vaasa. The coordination has been very hard, but meaningful and to the point. No, just kidding. And also WMW to the dissemination and keeping us also, and to the patience to keep us all in line and delivering the things we need to deliver. So, and of course all the partners. It's been a real pleasure. I think. Yeah, there's been pressure as well. Yeah. But luckily, we're still all on talking terms, and we answer each other's phone calls. So I think it's been a success.